Alright, let's do some Mathity-Math. So we got here a little practice quiz. Let's just go through this so you're super duper prepared for your actual quiz. Okay, so it says point A has coordinates jk and it's located on the graph y equals g of x. Okie dokie. So they say, well, why don't you identify the coordinates of the corresponding point of the graph of the inverse y equals, and this is just saying the inverse of that. Okay, so pretty much a straightforward function inverse type of question. So when we kind of go through these, one way we can kind of look at it is that it's just an idea of that if you have a function and then you want to find its inverse, in essence, you're switching the input and the output, right? So the input becomes the output, and the output becomes the input. So when we talk about input-output, the x value is the input, and the y value is the output, or you stick j in and k comes out, okay? That's the idea here. So when we look at this right here, when we say, okay, usually we're going to put in the j and out comes the k, right? Because these are coordinates. They're not giving us numbers. They're giving us variables. So it would reverse. So in essence, if originally I put in j and out come k, they're saying reverse the values. So they're saying for the inverse, right, my input would be k, and then my output would be j. And these are just variables because we're not giving variables. And boom, pow, and there you go. You're done. Let's do a fancy transition and go to question number 2. Okay, question number 2. Answer the following questions using the graph below. Okie dokie. So we have this image right here. This is our function. It says, well, what is the domain of the function? Okay, no big deal here. So the domain is just the x values where this image exists. Okay. So we can do this a couple different ways. Let's do this notation here. Okay, so we have the set for our domain, or we call that our x values. And let's see here. Over here, it goes and it includes -4. So we'll say that the smallest it goes is -4. The actual value that it is bigger than or going to be equal to -4, and that's because that's colored in. Okay, this is our x value, right? And it's traveling, x is occurring, it's occurring, it's occurring, it's occurring, it's because this whole way it's occurring, it's occurring, it's occurring, and then it gets here, it stops occurring right here because it doesn't go on past this, right? It's empty over here. So as when it gets to 5, then you know the domain is done. Oops, gotta actually put my symbol in here. There we go, sorry about that. And there you go. And then we're just going to finish up that set. Right? So that's the set of x values, which is also known as the domain. And so it's saying right here, like, this x value lives between -4 and 5 and everything up to and in between. That's how you do it. When we go to the next part for the range, it really is the same song and dance. So when we look for the range, that's the set of values for y. And again, we're just going to see where the low side and the high side. So if you kind of think about it, it's between here and here. That's where it is. And so this one is colored in. So it is filled in. So it is there and included in. So -3. It's only going to go up from there. So it goes up, 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 up. And that y value goes all the way here to 6. And there you go. That's it, right? So the y values, or your range, starts at -3, included into, and all the way up to, and including up to 6, and all the values in between. That's what that y means right there. Okay, next question is, what is f of -3? What this is saying is, if I input -3, what is my output? So our x value is our input. So I just go right here where my x is -3. Well, when x is -3, y is 0. Okay, so when I input -3 into this function, my y is 0, right? Another idea is like, what if I inputted a 1? If I inputted 1, my output is 6, right? Keep that idea going. If I input -1, then my output will be 4, right? So you just go to the x and then find the y where you hit your function. There you go. Let's go to question number 3. All right, we are here at question number 3. So here we go. It says the function f of x is all of this information right here, and it has this range. And when we look at this range, it's saying those are the y values. So basically it goes down, or continues to approach to negative infinity, it goes up, 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 up. It gets to 8 over 3. It doesn't include 8 over 3. We can tell by that by the parenthesis or the soft bracket. And then the same function, it continues on after 8 over 3 and does not include 8 over 3, and then it goes up to infinity. So essentially, it's every single y value except for 8 over 3. Okay, our job is to find the value of a. Now we can do this. We just kind of think about the story it's telling here. It's saying that the output 8 over 3, the function doesn't exist there. Well, if the function doesn't exist when the output is 8 over 3, there's also going to be an input that gave us 8 over 3, and that input also doesn't exist. So what we're going to do here is we're going to think about this, that this is our output or our y value, or what happens here. So instead of f of x, I'm actually going to put 8 over 3. Okay, this is the output that the function doesn't exist at, and that'll help us isolate some pieces of the puzzle. Specifically, you can isolate the x, which would be the input that makes the output that the function doesn't get to. Okay, kind of an odd way to look at it, but it is what it is. So I'll rewrite this information here, right? And so this can let us isolate x now, and then that will let us solve for a. And I'll explain that as I get a little further, because remember, we're looking for the x input that would make the y output where the function doesn't exist. Okay, here we go. So a little bit of old-fashioned cross-multiplying if you want. And what we're going to get here is we would get 3, let's write that down, we would get 3ax minus 15, right, because the 3 distributes there and there. And that is going to be equal to 24x minus 16. Okie dokie. Now we're cooking. Got some linear algebra happening here. We should be doing just fine with this. Now, the first mistake we usually see at this part is when we start trying to get all the x values on one side. When I move this 24 over by subtracting 24x from both sides, it does not combine here because this is a x and this is an ax, and they are not the same, not like terms. So I subtract 24x from both sides, and we get here. And I'm going to add that 15 to both sides. So there we go. That's just some nice little linear algebra there. Okay, so I have two variables. I want to isolate one. More specifically, I do want to isolate the x, because I want to find, again, I want to figure out where that x doesn't exist. Keep that thought in your head. I know I keep repeating myself, but it's an important thought. Okay, so when we have these two variables, typically factoring is a great strategy to go to. So look at this term, and look at this term. And what do they have in common? Well, they both have an x, and they're both divisible by 3, so I'm going to factor out a 3x. If I factor out that 3x, I'm going to be left with this a, and then I'm going to be left with this. So the x goes away, and 24 divided by 3 is 8. And that's all going to equal -1. Okay, so again, I'm just trying to isolate this x, so I'm going to keep it moving here. I have 3x multiplied by a minus 8, so the opposite of multiplying by a minus 8 is dividing by a minus 8. So now I'm going to have, I'll just put it up here. We have 3x equals -1 divided by a minus 8. Okie dokie. Almost got x all by itself. So the next idea here is, what do we got to do? Well, what's the it says 3 times x, so what's the opposite of multiplying by 3? Well, that would be dividing by 3. So this is going to give me x equals, I'm going to parenthesize all this to keep our information clear, a minus 8, I'm going to write it this way, so it's very clear, divided by 3. And I'll make it as a fraction, so we're only dealing with fractions, okay? All's well right there, no big deal here. But then, if we look at this, dividing is the same as multiplying by the reciprocal. So now it's x equals negative 1 over a minus 8 multiplied by 1/3. Okay, we're almost there. So we combine these, and so now you're going to get x equals negative 1 over, go ahead and say 3a minus 24, because I just distribute the 3 to the a and that to the 8. Okay, so now we know that x equals all of this. We're going to have to move down a little bit, but that's okay. We're here. So remember, the whole idea here was that we are trying to find the x value that doesn't exist, because that's the input that makes the output that also doesn't exist. Okay, so where can this x not exist? Well, that's going to clearly be wherever this denominator equals 0. So you can look at this and probably answer it, or think of it a different way to say, like, well, if I want to make where this denominator equals 0, I can just write that down. 3a minus 24 equals 0. Okay, so how do I get a all by itself? It's going to be 3a is 24, and then it's going to be a is 8, right? And so when a is 8, if you kind of plug that back in there, 3 times 8 is 24. 24 minus 24 is 0. And when the denominator is 0, the function doesn't exist at that point. So now we know the a value we need to plug into this function, right? And that will let us know where this input doesn't exist. So the answer is a is 8. Ta-da! Let's go to question number 4. All right, let's keep it going. Here we go. It says, given that f of x is negative 4 multiplied by the absolute value of x plus 3 minus 7, find the range of this function. Now, we can do this one 2 different ways. One, we can, let me just draw a line here. One, we could kind of start with the parent function and build it from there and see what happens. Or we could just graph it on our calculator and also try to find that range. So we got a calculator here. All right, so if we looked at this, we go to y equals, and we'll say negative 4. Then we go to math, abs, that's our absolute value, x plus 3. There we go. And then I say minus 7. Voila. Let's graph it, see what happens. Beautiful. And actually, this is kind of nice right here. This just shows us the shape of our absolute value. And looking at it, if you look at this table, the table that's showing here, this is really nice because this clearly shows where that vertex is at. That vertex is at y equals negative 7. And we can see that pretty clearly because it goes down on either side from there. So I know that if this vertex here is at y equals negative 7, my range is all of those values below it all the way down to negative infinity. So looking at that, we could say that our range is just y must be less than or equal to negative 7. That does that. Now that's using our calculator, but we could also actually approach this from a different direction, not using our calculator. So without using our calculator, we can kind of look at this parent function here, which is just an absolute value parent function. And so looking at this absolute value parent function, you know, if I input a value for x, it's going to create an output, and that output is everything over here. So if we just started with, and we can kind of build this thing up, okay, so if we just started with this parent function, f of x is the absolute value of x. And think about what we would know. We would know that this absolute value of x, if we put something there, it would create an output, and that output would always be greater than or equal to 0. So we know that whatever this is, it's going to be greater than or equal to 0. That would always happen. And if we did the next step of putting a 3 there, inside there, well, even that, it's the same idea, right? So we can, this is the parent function, let's move away from that and say that, well, even if I had this situation, x plus 3, because that's just going to be a horizontal shift, whatever that output is, it's still, the range or the output still going to be greater than or equal to 0. And now let's start looking at all these other transformations and see what happens. if I multiplied in a negative 4, well, when we multiply across a inequality, then negative 4, so now we would have this over here is negative 4x plus 3, right? That's right there. But that's going to flip our inequality, is because if you think about it, at that point our absolute value flips, so now everything that happens over here is going to be less than or equal to 0. Okay? So we're kind of building this process. And then we have this last vertical shift here, so if we subtracted 7 from both sides, and just kind of rewrite our entire thing, it tells you that everything that happens over here, whatever all of this is, now it all has to be what? Less than or equal to negative 7. That's saying our output, no matter what happens, is less than or equal to negative 7. And that is exactly what we got up here too. So you could also say whatever this is, whenever this happens, all of this, also known as your output, must be less than or equal to negative 7. So, there you go. That's question 4. Let's move on to question 5. All right, question 5. You see here we have a function, f of x. And they say, well, I want you to graph the inverse of that function. Okay, so we can do that. And remember, in essence, the inverse of a function is saying instead of wherever you had an input, that is now your output, and that output will generate your input. So, in other words, we just do the old switcheroo. So here we go. We have negative 2, 0. Which tells me, I'll write this down over here, I guess. We can do that. The inverse of negative 2, 0, we go to point 0, negative 2. And let's go there. 0, negative 2. There you go. There's 1. For here, we have 6 and 2.8. Well, that tells me then I should go to 2.8 and 6. So we have the point over 2.8 up 6. So I go over 2.8 and up 6, and that puts us about there. All right? From here, you could try to draw your sketch, but we could also try to find a couple other good points. Like, for instance, here, this one is 2, 2, so if we switch it, it's still 2, 2. That makes it very, very clear. And let's see, are there any other nice ones? Oh, here we go. This point right here is negative 1, 1. So the inverse of that is 1, negative 1, right? Because I was back 1 and up 1. So now I go 1, negative 1. So let's do it. Over 1 and down 1. There we go. Cool. And so now I think we have enough to draw ourselves a nice little sketch. Voila. And you've drawn yourself the sketch of the inverse. And remember, inverses, they are reflective across the xy axis, which is this right here. So that can also help you see it pretty nicely. All right? Good job. Let's go to number 6. Okay, looking at number 6, they tell us we have this function, and they tell us this domain range right here, because that's where it exists. And they say, here is the graph of f. So what is the inverse for negative 2? So remember, typically, when we had it before, this was saying you input negative 2. Right? And where are you at on the y? So now it's saying go to negative 2 on the y, and where are you at on the x? You're right here. And so we know that the answer is negative 4, right there, because we went down 2 and over 4 to find our function. There you go. That's that. Let's go to number 7. All right, number 7. Got a story here about a hotel owner draining the pool. Okay, and so we have the time. And remember, time is always independent. That's a fair indicator. This is our x information. And then they said the depth, the d of the water. And that makes sense that as the water drains, the depth is dependent on the time. So that is going to be our y. Okay, quick visual. Right, this is going to say this is our d, and this is our t. Right, time and depth. And so we're trying to find write an equation that models the draining process that gives us the depth d as a function of time t. So it's saying d of t. We write that like this, d of t. Okay. And looking at this, we can do this in a lot of different ways, but we're going to try to find d of t. So the first thing we could do is could just graph it. So let's see here. This would be 1, 2, and 3. We'll just do 1 and 2 and 3. That should get us close. So this said go over 0, up 1.6. That's about there. So go over 1 and up 1.5. Oh, excuse me, 1.45. That's there. Over 2. That's like 1.3. And then over 1 and 1.5. And you can see my little sketch. And you can see that this is making a line. And because it does drain at a constant rate, that's a big clue, constant rate. That lets you know that it is going to be a straight line. Okay, so the equation of a line, always y equals mx plus b, where b is our y-intercept, and y and x are y and x values, and m is our rate or our constant rate. So the first thing, great little test-taking thing here to think about, if they're going to give us what's happening when x is 0, that is always our y-intercept. So out the gate, we have our b value, which is 1.6. So if we were building this thing, we would say, well, y is mx plus 1.6. Okay, and we'll move this into DOT form when we're done. Okay. Next, we just need to plug in an x and a y, and that will help us find our m. Okay, so my x is 1. If I plug in a 1, I'm just going to get m, right? Because m times 1 is m, and y is 1.45. Okay, there we go. So I almost isolated m. Subtract 1.6 from both sides, and you're going to get m is negative 0.15. So we have m. So we could say y is negative 0.15 m plus 1.6. Sorry about that, not m. I'm sorry, m is right here. This is, we would say x. Okay, and then when we started rewriting it, instead of the x, we would say t. Okay, and then we put plus 1.6. There you go. And that DOT is that actually is your answer in the form of DOT. Okay. Also, something to look at here. If they give you a constant interval for your x, you could actually just do the math here to find what your m value is, or your rate, because from 1.60 to 1.45 it goes down 0.15. From 1.45 to 1.30 it goes down 0.15, and you get the point. So that could also be a quick way to find your m value. Okay, so anyway, there's your answer. Woohoo! Off to our next question. Let's go to number 8. Here we go. 96 exchange rate for euros to US dollars at 1.12, which means for every 1 euro, you get 1.12 US dollars. Let's stop right there. So just so we understand, we're comparing euros to dollars. In this case, they tell us out the gate. All right, forgive that scribble. I don't know how that magically appeared in this crazy world we live in. So if we look at this, it does tell us that 1 euro, so that's 1 euro, this is like my euro line, is equal to $1.12. Okay, and if I just kind of put this euro and dollar thing here to remind me to always keep my euros and my dollars where they need. Okay, and so now let's do the other side of, this is the rate the bank has, and the other side of the story, or the other side of the equation, is our friend Amelia. Amelia has US dollars, so over here for the dollars, we're going to say U, and she wants to convert to euros. Okay, so she wants E, we'll say E for euros. But the bank will charge her $10 for this transaction. So whatever money she has is actually going to go down by $10. All right. So they say, well, why don't you write me an equation that models this whole story? So we're working here, working on with this stuff right here. And this is nice because we have a fraction equal to a fraction, or a ratio equal to a ratio, so we can just cross multiply. So 1 times this is just going to give us u minus 10, and that's going to equal 1.12e. Awesome. And let's see here. It says, write an equation that models the net amount of euros she'll have. So that means we want to get euros all by itself. Well, we would have E all by itself if we simply divided both sides by 1.12. So E is U minus 10 divided by 1.12. And there you go. That will tell you how many euros she has. And we're done. Good job. Let's go to the next question. All right, here we go. It says, find me the range of this function. So that's just saying, what are the y values where this function exists? Again, we can do this a lot of different ways. if you had to do like a quick down and dirty sketch of this function, you know that it's going to be up 4, some things are going to happen, and it's going to be positive, so it's going to look something like this. Okay, that's just a loose sketch to get us thinking. So essentially, we're going to have some y values that are bigger than something and go on for infinity. Okay, that's just a loose kind of sketch to let us at least understand what we're trying to do. So how do we do that? Well, if you think about it, this point right here, this is our minimum. It's our vertex, but it's also the minimum, and it's only going to go up from there for our range. So we could try to identify that minimum, and the way we do that is by using negative b over 2a. We just look at our a, b, and c values. So our b value is 1. That's the coefficient here. So I have 1. Okay, and my a is 4. So 2a is 8. So I know that the x value, right, the x value of this vertex is negative 1/8. So how do I find the y value or the output? Well, I can just plug this x value of the vertex in, and that will tell me the vertex, which is also the lowest the y will go. So I just got to plug in negative 1/8. So we have this given to us right here. 4, I'll put negative 1/8 squared plus negative 1/8 plus 4. Okay, we can go from here. Negative 1/8 squared is 1 over 64. Okay, minus, plus negative 1/8, let's do that, plus 4. Okay, if we multiply this in, you're going to get 4 over 64. And we can actually simplify, well, you know what? Let me just do some good math for you. We do 4 over 64 minus 1/8 plus 4. Okay, this can clearly simplify down by dividing by 4. So that's going to be 1 over 16. So this, when simplified, is now like saying 1 over 16 minus, now 1/8. Instead of 1/8, I need to move it into 16 so I can subtract it. So 8 times 2 is 16, so I do 1 times 2, so I get 2/16 plus, well, 4 moving into 16ths. 4 times 16 is 64. So now we're all in 16ths. We all have common denominators. So now we can just go ahead and solve this thing. 1 minus 2 is negative 1, and negative 1 plus 64 is 63. So I have 63/16. That's my y value of the vertex, and it only goes up from there. So I know that all my y values, okay, all my y values will be bigger than this or the same as this. And that right there, that's the range of my function. All the y values. Y is always going to be this equal to this, that's the lowest, or it's always going to go up for infinity. All right, there we go. Let's go to our last question, number 10. All right, so we have a one-to-one function f. It's given in the form of this ordered pair below. So they say, well, what is the value of f of 10 plus the inverse of f with where it's negative 2? Okay, pretty fun question, actually. So f of 10, they're saying when the input is 10, what's the output? Or when x is 10, what is the y? So where is x 10? Oh, here it is. So when x is 10, y is 4. So this is just like saying 4. Okay, and so now this is saying when, for the inverse of negative 2, so instead of finding where x is negative 2, we just find where y is negative 2. So where is y negative 2? Right there. And so y is negative 2, and the input was 0. So now it's just 4 plus 0. And there you go. What is 4 plus 0? 4 plus 0 is 4. And boom pow, we did it. We are done with the SL portion of this practice quiz. The next video will be the HL portion. Okay, so you can go there next.